This UCSD TV program is a presentation of University of California Television for educational and non-commercial use only.
This is a podcast of Scripps Institution of Oceanography at UC San Diego. To learn more about how you can support Scripps, visit us online at scripps.ucsd.edu. For 50 years, satellites have been roaming the skies collecting valuable information on Earth. They have quickly become a critically important scientific tool to study the global environment and can offer much-needed insight into the future of our planet. Scientists at Scripps Institution of Oceanography at UC San Diego use Earth-orbiting satellites to tackle global environmental problems.
I think in any discipline of the earth sciences that you can think of, or certainly all the disciplines represented here at Scripps, the progress that has happened not only since 1957, since Sputnik, most importantly since basically the mid-70s to now, when we started being able to collect and manage those data, is visible in all disciplines. So we see our understanding of the Earth from the outside all the way to the middle, to the core of the Earth, increased enormously by just the very virtue of having global, continuous observations associated with satellites. One thing that has happened over the last 15 years is we know the topography of the ocean globally to an amazing precision, to an inch or so, depending on how much you want to average. And that has changed drastically not only our understanding of what the ocean bottom looks like, but also how ocean circulation happens. It has allowed us to tie this with space and surface-based observations of sea surface temperature.
Scripps geophysicist Hella Amanda Fricker, an associate professor in the Institute of Geophysics and Planetary Physics, uses satellite observations to study the western Antarctic ice sheet in an effort to understand one of global warming's most dramatic consequences, sea level rise. Scientists predict that even small changes in ocean levels can place coastal cities underwater and disrupt entire ecosystems. Using NASA's Ice Cloud and Land Elevation Satellite, or ICESat, Fricker noticed astonishing changes in the ice sheet, signaling that a complex system of active water lakes exist beneath.
So we discovered the areas on the ice sheet where the surface elevation was changing by several meters. In one place we saw a change of 10 meters. We saw the surface actually was drawing down by 10 meters over about nearly 3 years. And we interpreted that after looking at across the whole system. We realized this was happening in many places and that some of these changes were occurring in phase and some of them were out of phase, so the lakes were actually linked to each other. We interpreted it as being the movement of subglacial water underneath the ice sheet. And what we were seeing was the surface response to the water moving beneath the ice sheet.
Meanwhile, on the Big Island of Hawaii, hot magma is blazing new trails beneath Hawaii Volcanoes National Park, and Scripps professor David Sandwell, with the help of satellites, is able to closely monitor new subterranean volcanic activity. On Father's Day 2007, the eastern portion of the Kilauea volcano on the Big Island woke up after more than 30 years. The east rift of the volcano, part of a complex subterranean plumbing system, is exhibiting new motion that could affect residents living on the volcanically active island.
We call it the Father's Day Rift event because it began on June 17th of this last year. During that event, what happened is there was a dike injection. A dike intruded into the ground. It opened about 2 meters or 6 feet, and that was first detected in GPS data. Fortunately, we had synthetic aperture radar data before the event, and we could use that along with an acquisition taken just after the event to make a very nice looking interferogram, a complete map of the ground deformation.
Scripps researchers are eager for the next generation of satellites to push science into the future and greatly increase their understanding of global environmental change. Science has reached a pivotal point in understanding and modeling the Earth's climate system. In order to predict what will happen to the climate over the next 100 years, scientists need precise satellite observations to feed their models.
In the near future and the coming years, we're going to have a lot more satellites, maybe hundreds of satellites used to monitor all types of things like climate change and earthquakes and so on.
What is changing right now is we have the capability of modeling those data and modeling their evolution to where we are developing the possibility of predicting what's going to happen, and predicting what's going to happen locally over a few days, that's the weather, or predicting what's going to happen over decades or even century globally, and that's studies of the climate. I guarantee you that 50 years from now, as we accumulate more data and have a longer history and have better computer models, we will probably look back and think about 2008 as being the pioneering era of Earth system modeling.
This has been a presentation of Scripps Institution of Oceanography at UC San Diego.